Good afternoon, everyone. I hope you people are doing good. Please do reply in the chat box. Good afternoon, Vignan. How are you? Hello, Divana. How are you? Divana, you haven't turned out. So, how many YouTube friends are there listening? Hello, Divana. Hello, YouTube friends. Okay. Yes. So we have seen like students are coming, and let me start discussing about some of the important points which we have discussed. That is, I've given the introduction for redox reactions, right? So in redox reaction, basically what we have seen, what is a redox reaction? Can anybody tell me in the chat box? What is the redox reaction? Can anybody tell me in the chat box? Hello, Nilima. Hi, Nilima. How are you? I'm good, Nilima. How are you? Yes. So Lavanya NPC is also joined. Hi, Lavanya. How are you? Okay. So it is very good to start. You people have been there here. So still we'll wait for another 2 minutes, then I can start. So now, before going to discuss about these things, many people might have know this, right? Redox reactions, where it involve both reduction reaction and oxidation reaction. Thank you, Lavanya. Okay, so redox reactions are nothing but both redox reaction and oxidation reactions are usually observed. Okay, so basically, if I'm talking about redox reaction, so first, if I'm talking about redox reaction, so if you see yesterday, I told you what I am going to tell you is that in case if there is a decrease in oxidation number, this is +2, and if it is going to 0, then I have told you that some of the important points. Redox reaction is nothing but it is a gain of hydrogen or less electronegative atoms. They have to gain. That is, if you see, they are gaining the hydrogen, or we can say this is less electronegative compared to nitrogen. Okay, so nitrogen electronegative is almost 3.5. Hydrogen will be 2.1 or 2 point something, right? So next one is they are loss of hydrogen, loss of oxygen are more electronegative element. So if you see in the case here oxygen is there, now it has been loose. So that's why we are going to call it also reduction. So reduction basically addition of hydrogen, and another one is the loss of removal of oxygen. Third one we can say gain of electrons. Fourth one we can say that increase in the oxidation state. So if you see here, so this ferrous ion, okay, is going to consume these two electrons and it will become ferrous. Okay, so it will take these two electrons, it will going to gain the two electrons to become iron. So this is what next. There is a decrement in the oxidation number. So basically redox reactions, if you see, okay, redox reactions, if you see, so redox reactions are nothing but gain of hydrogen or less electronegative element, loss of oxygen or more electronegative element. Okay, now, so gain of electrons, you just now see ferrous ion to ferric ion. Okay, so next, there is a decrement in oxidation number. You can see +2 and it is moving to 0. That means +2 is becoming 0. That means we can clearly say that there is a decrease in the, okay, oxidation number. If the oxidation number is also decreases, then you can say it is, a reduction reaction. Hello, Palka team. How are you all? I'm very happy to see Palka team here. Okay, so warm welcome to you. Okay, so then next, Nidhi, can you unmute yourself? Nidhi, can you connect to audio? Connect to audio, ma. If you want any help, please let us know. If you want any help, please let us know. But try to connect the audio. Okay, I think without audio you can't hear. So there is a option you can click in your phone if you are using first time, then you can do it. Okay, we can see, right? So that's what you people need to remember. And next one, you can see here. Okay, so this is what the reduction reaction definition. We have seen this earlier, and later on we started talking about oxidation reaction. So basically, oxidation reaction, if you see in oxidation reaction, we can clearly say that it is nothing but, okay, addition of oxygen and removal of hydrogen. So, and next one is there is increase in the oxidation number. So let us see point by point. That is loss of hydrogen, Hello, G Navya, how are you? Okay, so that is loss of hydrogen and loss of less electronegative atoms. So that is you have to loss of hydrogen in case if you see hydrogen is being lost, okay, and less electronegative. So compare between oxygen and hydrogen. Hydrogen is less electronegative. Losing of hydrogen or less electronegative elements indicates oxidation reaction, and we can also say gain of oxygen or more electronegative. You can see here magnesium is gaining oxygen to become 2MgO, right? Whereas you can see third one, that is loss of electrons. You can see copper is going to lose these two electrons. Copper is losing two electrons. When copper is losing two electrons, again we can going to call it as oxidation number. Okay, very good. So we have seen very good aspirants here. Okay, right. Toshika is joined, Nandini is joined. I know like you people are joined little late, but we haven't started much. Okay. Thank you. I hope Palka team you have sorted out your issues. So you can see, you can hear my voice clearly. I can see you how much your teachers are making the efforts for you to arrange the class. Okay. So that is a good sign to start. Right. Yes. So now we can see that oxidation reactions are basically loss of hydrogen, and we can also say less electronegative atoms, gain of oxygen. You just see in this equation, it was magnesium is gaining the oxygen, or we can say the oxygen was addition was takes place. So, or we can also say more electronegative element. And third point, loss of electrons. Just now I show you. So copper is going to lose two electrons by forming cuprous ion. Sorry, cupric ion. Next one, third one, fourth one will be, last point will be, you can see here, this copper is going to lose two electrons. This copper is going to lose two electrons by forming Cu plus 2 ion. Okay, so copper is going to form Cu plus 2 ion by losing two electrons. It will lose two electrons. Okay now, so last one is increment in the oxidation number. You can see there is a increment in the oxidation number. Increment, or we can also say there is a increase, there is an increase in oxidation number. So in case if you see these four parameters, then you can say these are oxidation reactions. Next, we have talked about the like final. What is the exact difference between redox reactions is nothing but, so this is hydrogen, oxygen for reduction. Okay, gain of electrons for reduction. There is a decrease. There is a decrease in oxidation number for reduction reaction, whereas there is an increase in the oxidation number for redox reaction. Oil rigging, you know that, to remember it is oil rigging. What is oil rigging? You are going to rig the oil for the crude oil you are going to get from the oceans and seas. Okay, from there you are going to rig the oil. So that is nothing but oil oxidation. Okay, that is nothing but loss of electron. Reduction is nothing but gain of electrons. Okay, now I hope you people understand. Now in this reaction, now I want you to tell me. Yesterday we solved these type of questions. Where is oxidation is happening and where is reduction is happening? Can anybody tell me in the chat box? I have already given the answers, but I just want to know where the oxidation is happening, where the reaction is happening. So if you see in this case, this is zero oxidation state and this is zero oxidation state. And if you see, there is a decrement in oxidation state and there is increment in oxidation state. Here, oxidation state increases, okay, whereas in this case, oxidation state decreases. So if the oxidation state decreases, we call it as reduction or oxidation. If the oxidation state decreases, we call it as reduction or oxidation. Come on, tell me in the chat box. If the oxidation number decreases, it is a reduction or oxidation. Hi Jyoti, how are you? Thank you so much. Jyoti Thakur, thank you. Dance Battlefield, also thank you for your response. Good afternoon. Okay. Yes, very good. I got a response from her. So you can clearly say that, okay, so here this is nothing but oxidation because there is we can say, sorry, there is a decrease in oxidation number, so that's why you are going to call it as reduction. Okay, so if there is a decrease in oxidation number, you are going to call it as a reduction. If the oxidation state increases, then you are going to call it is a oxidation. Okay, so I'm going to tell you here. So that is nothing but you can clearly observe, +1 state से 0 हो रहा है, that is reduction. 0 से +1 हो रहा है, that is oxidation. So yesterday only I told you, okay, if which is involving in reduction itself act as oxidizing agent. Okay na, and which involves in oxidation itself act as a reducing agent. These are the basic facts we have studied in the previous class. So let me test you about the concept test today. So I want among these three, okay, among these three reactions, we want where is oxidation is happening, where is reduction is happening. All I want is like, where is oxidation is taking place, where is reduction takes place, what is reducing agent, what is oxidizing agent. So can anybody try and tell me, my dear YouTube friends? Try to tell in the chat box also, right? Try to find out the answer. Try, you can try. At least first one you have to do. I didn't see any response. Okay, so if you are really facing any trouble here, please let me know in the chat box. Okay, let us see individual cases here. So now, in case if you see, I have provided you the answers here already. The reason because we are lacking of time. So now in case if you see, this is +2 and this is 2 minus and this is 0. So here this is +1 and this is -1 and this is 0. So you can see this is -2 and it is becoming 0. So from -2 से 0 हो रहा है. Now tell me, value is increasing or decreasing? Value is increasing or decreasing? Tell me in the chat box. Value is increasing or decreasing? Come on guys, tell me in the chat box. Value is decreasing or increasing? Come on, Palka team, come on. Others, you can try. Kalpana, Nidhi, very, very good students are there here. Okay, you can try. Value is increases or decreases. Can you guys hear me? Guys, am I audible to you? Please do tell me in the chat box. Yes, very good, Kalpana. Thank you. So the value is increases. So if the value is increases, we are going to call it as oxidation. If it is oxidation, definitely in this case, what is exactly happening? So 0 to -1, that is nothing but 0 to -1 it is becoming, that is nothing but reduction is taking place. If there is increase in oxidation, we are going to call oxidation number, we are going to call it as oxidation. If there is decrease in oxidation number, we are going to call it as reduction. So that is why I already told you, where is the oxidation process involved. In that case, that particular agent will acting as a reducing agent. So chlorine is acting as oxidizing agent. And itself undergo reduction. H2S is acting as a reducing agent, itself undergo oxidation. Okay. So now in this case also you may see here, aluminum is 0 and here also aluminum will become +3. So it is increase in oxidation state. And if you can see here, it is +3 and it is becoming 0. So that means there is a decrement in oxidation state. So very clear, ferrous sulfate is decreasing. So that means it is undergoing reduction process, right? Whereas aluminum is becoming Al+3, this is nothing but oxidation. Okay ना? So +3 से 0 हो रहा है, aluminum ferrate से फेरिक सल्फेट से फेरिक ऑक्साइड से आयरन बन रहा है, तो यहाँ आपको रिडक्शन होगा. ठीक है, एंड दूसरी बात ये है कि अल्यूमिनियम से अल्यूमिनियम ऑक्साइड बन रहा है, यहाँ आपको क्या हो रहा है, ऑक्सीडेशन. यू कैन डायरेक्टली से नो बिकॉज एडिशन ऑफ ऑक्सीजन आल्सो वन ऑफ द रीजन, right? So this is the homework for you, you can do it, right? So these are the questions you people need to study hard. Okay, so just now I was mentioning each and everything. Okay, now you can see where is oxidation and where is reduction, right? Yes, very good, right? Yeah. So now we talked about yesterday, that is electrochemical cell. So whenever we started talking about electrochemistry, whenever we talking about electrochemistry, basically what we have talked, we talked about the electrochemical cell. Okay, na? What is electrochemical cell? Many people will have a doubt that what is electrochemical cell. Okay, sir, what is electrochemical cell? Can you explain us? What is electrochemical cell? Can you explain us? Many people will say, right? What is the electrochemical cell? Can anybody tell me in the chat box? It is nothing but it is the, okay, it is nothing but what? Yeah, it is nothing but interconversion of electrical energy and chemical energy. Right, electrochemical energy is nothing but, okay, electrochemical cell is nothing but it is the interconversion of both electrical energy and chemical energy. Next, we have seen there are two types of electrochemical cell. One is galvanic cell, that is we can also call it as voltaic cell. Next one is electrolytic cell. Okay, so what is the function of galvanic cell? Can anybody tell me what is the function of galvanic cell? Come on, guys, in the chat box, you can try. Very good, Nandini. Very good, Nandini. Very good. Can anybody tell me what is the significance of galvanic cell? Galvanic cell का significance क्या है? What it going to do? What galvanic cell is going to do? Come on, guys, tell me. What galvanic cell is going to do? Yes, I got some responses. It contains anode and cathode. Yes, before that you can say it is using chemical, it is using chemical energy, okay, and it will produce as electricity. It will produce as electricity, and this particular process is nothing but spontaneous process. This particular is spontaneous. Spontaneous, yani it will become, it will going to do on its own self. There is no external resources required. Whenever you connect those setup, whenever if you make a setup by the action of chemical reactions, by the action of chemical reactions, you are going to, by the action of chemical reactions, you are going to see the function of galvanic cell. Okay, so the chemical reactions, you are going to produce electricity, that is spontaneous. Spontaneous yani apne aap hona. Okay, next we discussed about galvanic cell. This is how the basic setup of galvanic cell looks. Okay, you are having two beakers and there is a salt bridge. Okay, one you call it as a metallic plate, you call it as anode, and another metallic plate you call it as cathode. Why the charge is negative on anode, why the charge is positive on anode? Inside, when I discuss deep about galvanic cell, I'll tell you. But now I am classifying. So what I am supposed to say here is like galvanic cell is used for the chemical energy to produce electricity. Okay, galvanic cell or voltaic cell is used to what? Galvanic cell or voltaic cell is used to interconvert, is going to convert chemical energy to electrical energy. Okay, next, if I am going to talk about, so just now I told you, okay, just now I told you it is used for the chemical energy of a spontaneous reaction. Okay, chemical energy of a spontaneous reaction. Okay, chemical energy of a spontaneous reaction is converted into electrical energy. That is what we people need to know, right? Very good. Yes. So now, very good, Swati. Thanks for joining. Okay. Very good. I hope you people understand this one. Thank you so much, guys. In my dear YouTube friends, can you understand this one? Please do reply in the chat box. And next we discussed about what? We discussed about electrolytic cell. Basically, the main function of electrolytic cell is reverse of galvanic cell. The main function of electrolytic cell is reverse of galvanic cell. That means using the electricity. It is using the electricity to produce the chemical reaction. So you are applying some external source. Whenever if you are using some external source, then you can say it is a non-spontaneous reaction. Then you can say it is a non-spontaneous reaction. Okay. So basically galvanic cell is a spontaneous because the chemical reactions without any other influence, they will conduct electricity. Whereas electrolytic cell, it will use the electricity to produce non-spontaneous chemical reactions. It is used the electricity to produce non-spontaneous chemical reactions. Okay, sir, what is non-spontaneous? Many people might have a doubt. What is non-spontaneous? And if you see, this is your home. If you see, this is your home. Okay, this is your home. Let's suppose. So this is a tank. This is what? Tank. Okay, now. So now you have groundwater. This is your groundwater. So to take the groundwater into the tank, what you are going to do? You are going to use motor. You are going to use what? Motor. Motor is nothing but you are using some external source. Motor is nothing but you are going to use some external source. So this external source, with the use of motor, you are taking the groundwater to the tank. That means some applied force is there. Without any influence, it can't go. It has to give some energy. So these are nothing but non-spontaneous process. So electrolytic cell also comes under this category. Electrolytic cell is also comes under this category. I hope you people understand this one. If you clear with that, please let me know through the chat box. If you are clear with that, please let me know through the chat box. Is it clear? Right. Thank you, Lavanya. Thank you so much, ma'am. Right. So now, next we are talked about electrical energy. The basic electrolytic cell looks like this. It is an energy conversion, okay, carried out in non-spontaneous reaction. Then we started discussing about galvanic cell, right? Very good, Kamba Nilima, thank you, ma. Okay. Next, we talked about galvanic cells. What are galvanic cells and how you are going to use them, right? This is what we have discussed, right? So the galvanic cell, if anybody asks you, okay, it is the electrochemical cell that converts the chemical energy. Just now we told you galvanic cell is using chemical energy, okay, chemical energy, and to produce electrical energy, okay, and this is held by spontaneous process. Spontaneous process means it will do by own self. So some of the important character features of galvanic cell is it converts the Gibbs energy from a spontaneous redox reaction into electrical work. So what is exactly saying? What is the meaning of Gibbs energy? Gibbs energy is nothing but, let's suppose if you are having some chemical molecules, whenever they are going to collide, they will release some energy. What will they will do? They will release some energy, right? This is nothing but Gibbs free energy that is represented by delta G. So the significance of delta G is nothing but it is helpful for the work. Okay, energy, it is helpful for the work. But how it is going to helpful? It is using chemical reaction and it is producing electricity. So the process completely from chemical to electricity is depending upon what? Delta G. So that delta G can also explain whether the process is spontaneous or non-spontaneous. If it is a spontaneous, you need to follow something. If it is a non-spontaneous, you need to follow other thing, right? So now you can see here, for example, in a redox reaction of zinc, aqueous copper sulfate produces voltage of 1.1 volt under standard conditions. What is saying? They have taken a aqueous copper sulfate. So I am writing here aqueous copper sulfate, and try to remember CuSO4.5H2O. This is, many a times they asked in the examination, how many water molecules is attached to this substance CuSO4 में water molecules कितना present है इसके अंदर, you have to do it. Okay. Okay, so they have taken a aqueous copper sulfate and they kept the zinc rod. Okay, so this zinc rod, and they started seeing a difference between these two. Whenever they see the energy difference between these two, that energy difference is nothing but voltage. It is called as 1.1 voltage. Okay, so copper sulfate is there and you kept zinc. Okay, copper sulfate is there and you kept zinc. So that both are having what? Both are having a reaction and they produced some electricity which is 1.1 volt. So you can represent like this. So in generally, zinc plus copper sulfate will give rise to copper plus zinc sulfate. Okay. So now basically galvanic cell consists of two parts. Okay. What about galvanic cell? Galvanic cell is having two parts. One is anode part and another one is cathode part. So basically anode is nothing but donation of electrons, right? And cathode is nothing but what? Cathode is nothing but acceptor. Cathode is nothing but acceptor. This is the basic fundamental thing you need to do, as I was already mentioned there, but you need to know it. Okay, now. So next, if you see, if I am going to talk about this one, so the main setup of galvanic cell. Now we are going to see the main setup of galvanic cell. How the galvanic cell exactly looks. So you have taken zinc nitrate solution. This is zinc nitrate solution where the concentration of zinc nitrate is 1 molar. Okay. Next you taken a metallic plate. You taken a metallic plate. Okay, which you call it as an electrode, which you are going to call it as an electrode. Okay, basically this metallic rod is nothing but a consists of metals only, that is helpful for the electrons to transfer from one place to another place. Okay, now next I have taken, so this is the internal mechanism. Okay, this is the internal mechanism that PPT is helping. Zinc से Zn plus 2 हो रहा है. Okay, zinc से Zn plus 2 हो रहा है. You can see zinc से Zn plus 2 electrons. Many people will have a doubt that, sir, why is zinc is losing? Why not? How can you say the zinc is losing the electrons? The reason you can see, this is also a physical experiment. If you connect the same kind of things in different solutions, and after some day, if you see, you will change the dimensional change. You know, वस्तु का size decrease हो, है ना? So that is nothing but you can also say that by physically you can say that is this is going to be happen. Okay, so here the zinc is called as anode. Here the zinc is called as anode, and the sulfur whatever the solution is there, you are going to call it as electrolyte. You are going to call it as electrolyte. Clear? I hope everybody understand this one. I hope everybody understand this one. I have explained this earlier, but I am again trying to explain you. Okay. So now you are going to see the cathode part. Cathode part, what it will take? It will consume the electrons. Okay. Cathode, it will consume the electrons. How it is going to consume the electrons? These electrons are carrying by whom? These electrons are connected. These electrons are connected. So electrons are moving in this direction means current will move in this direction if the electrons are moving in this direction. So the current will always flow in the opposite direction of the electron. Okay. So this is what you people need to remember. Okay, so basically galvanic cell का मतलब क्या है? It is uses, okay, it is uses this galvanic cell. Basically it is used for the production of electricity by using the chemical reaction. So you can see these are the chemical reactions. So these chemical reactions are responsible for the production of electricity. Okay, this is you need to remember. So this is voltmeter here as it is mentioned. And next, so this is the overall cell reaction. Zinc is going to become Zn plus 2, copper is going to become this one. Now tell me, where is oxidation is happening, where is reduction is happening? Come on, anybody tell me where is oxidation is happening and where is reduction is happening? Come on, students. Come on, students. If you people are not at all responding, then I can finish the class. Come on, students. You have to answer this. Yes, here you may also clearly see, that here zinc 0 से +2 हो रहा है. So if the 0 से +2 हो रहा है, तो यहाँ oxidation state increase हो रहा है, and then this is called as oxidation, right? Whereas in case if you see here +2 से 2 electrons ले लिया, तो फिर ये हो गया आपका 0. So that is +2 से 0 हो रहा है. So that is nothing but oxidation state decreases. You can going to call it as a reduction. You are going to call it as reduction. I hope you people understand this one. Very good, Navya. Very good, Kalpana. Super, super. You people are really doing good job. Okay, right? I don't know about my YouTube friends, what they are going through. Okay, yeah. So now, now next to see what is exactly happening in galvanic cell. Okay, so there is a center, there is a inverted U-tube is there. This is called as salt bridge. We'll talk about the functions of salt bridge in the later class. So this is before and this is after. Okay, so this is before after. Before you can see before both are having same dimension. This is before, but after conduction of electricity, or we can say by using the principle of galvanic cell, we can observe that metal A is becoming thin, metal B is becoming more bit. The reason because here is metal A, which is at anode, it will lose the electrons simultaneously ions. So these electrons are flow towards the cathode and become what? And become deposited on the surface of it. Okay, so now you can see here net cell reaction. Okay, and next, yes, so it is very easy. Left side anode, next oxidation and having negative charge, that you people need to remember. So once again we can see here, yes, this is the complete setup of galvanic cell. You'll have two beakers. In one beaker copper sulfate. Okay, you have a two beakers, that is one you are having copper sulfate or copper nitrate. Second case you are taking something zinc sulfate and zinc nitrate. So both you are taking. So left side one we always consider as anode, and lone is nothing but loss of electrons. Okay, that is nothing but oxidation, or in other means left oxidation anode negative. Lone is nothing but left oxidation anode negative. Whereas the right side also I have given a trick. The trick is RRCP. What is meaning by RRCP? Rajasthan Royals never won IPL Cup. Sorry, Rajasthan Royals won the first IPL Cup. Rajasthan Royals won the first IPL Cup. That is, we can also say that right reduction cathode positive. What you are going to say? Right reduction cathode positive. Okay, right reduction cathode positive. Okay, this is the overall reaction you people need to remember. Okay, now yes. So next we are proceeding further. First, just now only we talked about deep about anode. Basically, anode is nothing but it will donate the electrons. Okay, it will donate the ions, and whereas the electrons will reach through the surface of the anode, whereas the electrons is reaching the surface of the anode. Clear? Okay. And next one is oxidation occurs at anode and releases electrons. Okay, oxidation is occurs at anode and releases electron. Just now you can see oxidation is happening and releases an electron. Next, hence anode is called as oxidation half cell reaction. Why anode is called as oxidation half cell reaction? Because in anode we observed that it is losing the electrons and simultaneously the oxidation state is decreasing. If the oxidation state is decreasing and it is losing the electron, we are going to call it as a galvanic cell. Basically, it is called as anode half cell. We can also call it as oxidation half cell, or you can also call it as anode half cell. And the anode charge is negative. Why? Can anybody tell me why the charge of anode is negative? Because all the electrons will come near to the surface of the cathode, the surface of the anode, so that the surface of the anode will become, okay, what? Negative. The surface of the anode will become what? Negative. I hope you people understand this one. And next one we discussed about during oxidation, positively charged ions would enter into the electrolytic solution. Okay, na? So during oxidation, positively charged ions would enter into the electrolytic solution. You can also say here, so it is going to lose Mn plus 2 ions, Mn plus 2 ions. That is what? Mn plus ions, Mn plus ions, Mn plus ions. What is this Mn plus ions? That is nothing but metallic ions only, where they are going to come from the solid state to ionic state inside the solution. Whenever they are going to produce the ions, they will also lose the electrons. Clear, everybody? And next, we can also see that from the Daniel cell. So one of the example for galvanic cell is Daniel cell. Daniel cell, they taken zinc rod, okay, and they done the electrolytic solution. Okay, so for example, in Daniel cell, anode is dipped in the electrolytic solution, and the oxidation at the zinc takes place given below. So whenever they dipped the zinc rod, they have observed the oxidation. Okay, that oxidation is nothing but zinc is going to give 2 electrons. And next one, if you see cathode part, basically this is called as electron acceptor part. It is very beautiful and very cunning. It is not doing anything. So simply the solution consists of copper sulfate. These copper ions is going to revolve and going to consume these 2 electrons. Copper ions is going to consume these 2 electrons and will become copper. Okay. So in case if I am talking about copper, sir, is it only valid for copper? Galvanic cell is valid for everyone. Whatever the metal may be, metal is consuming 2 electrons and becoming a solid. Okay. So we can also say that cathode is nothing but reduction, where the reduction will occur. Okay. So basically cathode reduction occurs at cathode, and whereas accept electron will be from external circuits. It will accept the electrons from the external circuits. And next we called cathode is happening reduction. So that's why we are going to call reduction half cell reaction. Okay, na? Sir, cathode, why the cathode is having positive charge polarity? The reason the positive charge polarity, all the positive signs is approach near the surface of it. All the positive charges will near the approach to the surface. So that's why we are going to have the polarity. That is called as positivity. Okay. And next, during the reduction, positively charged metal ions gets reduced and deposited on the electronic surface. Yes. So whenever there is a reduction is taking place, metal ions are going to reduced and deposited on the electrode surface. Next one, this is another example. Daniel cell, if you take cathode as a copper ray dipped in the aqueous copper sulfate solution, and the reduction of copper ion takes place. Okay, so you may see the Daniel cell may be taken cathode as an copper. Okay, so that's why what they are going to say that copper sulfate के अंदर जो ions हैं, those ions are responsible. These ions will going to gain two electrons and become a cell. Okay, I hope you people enjoyed it. Okay, so galvanic cell is formed for both oxidation electrode and for the reduction electrodes. Okay, now, so for example, Daniel cell, if you can see, for example, Daniel cell, you can see this is the setup of the Daniel cell. Zinc will lose the electrons. Okay, zinc will lose the electrons, and copper is going to take the electrons. Okay, zinc will lose the electrons, and copper will take the electrons. So that means electrons will flow in this direction, and the current will flow in this direction. I hope you people understand this one, right? Yes. Okay, guys, that's it for today. Okay, we'll meet you on Monday. Okay, Monday or Tuesday. I hope you people really enjoyed it. Okay, this little bit theory is there, and I'm feeling headache, so I couldn't concentrate on the much. So definitely next Monday we are going to meet. That means next week, and I'll help you for sure. Thank you, guys. Thank you for joining the class, and we'll see you next Tuesday. Bye, everyone. Bye, bye. I'm not feeling well, so that's why I'm leaving early.